In this video, we're going to discuss numerical or quantitative data. This will include summary numerical measures and some graphical displays. Let's start with the numerical measures. One of the very important numerical measures is where the data is centered. There are three popular statistics for measuring the center of the data. There is the mode, which is the least reliable, and that's the one that occurs most often. It's the least reliable because it varies the most from sample to sample. One time you get a mode of 59, another time you get a mode of 48, etc. The median is more reliable. It's the data value that's in the middle. It's the 50th percentile. You order the data from smallest to largest. You pick the middle. That's the median. It's much more reliable because it varies less from sample to sample. The other thing that's very important in numerical measures is the variation or the spread of the data. Again, there are three popular ways of doing that. There is the range, which is the maximum minus the minimum. And as you can imagine, that varies a lot from sample to sample. The second is the interquartile range, which is the difference between the 75th and the 25th percentile. The symbol for the 75th is Q3. The symbol for the 25th is Q1, third quarter, first quarter. And then we have the standard deviation, which is the most reliable. It measures how far each data value is from the sample mean and then squares it so positive and negative deviations won't cancel each other. And then we add those all up and we divide by n-1 to average all of that out and kind of get an average deviation. The problem with that is, I'll show you in the formula what the problem is. So let's go back to the interquartile range. For a better understanding visually of what the interquartile does, is you order it from smallest to largest. The first quartile measures the point at which 25% of the data is below that value. Then we have the median, which is also symbolized as Q2, and that is the number so that 50% of the data is below it and 50% of the data is in the middle. It's the middle point of the data. Then we have the third quartile. The third quartile, we have 75% below it, and as a matter of fact, 25% above it. So that's what the third quartile is. The interquartile range measures the width of the middle 50% of the data. Think of it that way. So it's Q3 minus Q1. It's how wide the middle 50% of the data is. Then we come to the standard deviation. This is something I have to show you, and it's the reason we rely on computer software, in our case StatCrunch, to give us that number. But here it is. You take each data value, so you subtract the sample mean. You don't like the fact that positive and negatives cancel, so you square it, everything's positive. You add all those up, you get the sum of the squared deviations. You take the average. Problem, the units are wrong. If your units are grams, the units will come out grams squared. That's not good. So we take the square root, and we're back to the original unit, grams. That's all I can tell you about the formula, and don't worry, you don't have to do it by hand. Okay, a visual. I always think visuals are better than formulas. So the top graph shows a large standard deviation, which, now these are population standard deviation, population mean, population standard deviation. So a large standard deviation means the data is far away from the mean. And so it's kind of a flat distribution. Bottom graph shows a small standard deviation. Standard deviation is closer to the mean. And if you'll notice the shape, it's more peaked. It's narrower. So we're leaving summary measures of numerical data, and I'm going to show you the two most popular graphic measures, or displays rather, of numerical data. One is the histogram, and you're probably familiar with that. Again, you arrange the data from smallest to largest. The smallest data value might be 10, and the largest is 60. And you decide on class intervals of equal length. And you count up, and you should have 4 or 5 or 6 class intervals. That's convenient and appropriate. So then you count how many observations in first class interval, second, fifth, 5, 4, 2. So the height of the rectangle represents the frequency. This is 3 units tall. This one's 6 units tall, 5 units tall, 4 units tall, 2 units tall. These values along here are the midpoints. Some graphs, they're going to give you not the midpoints, but the boundary values. The 10, the 20, the 30, the 40, the 40, the 50, the 50, the 60. Notice something. You're thinking, this looks like a bar graph. The difference between this and a bar graph is they are all connected, okay? So daily temperatures are what we call a continuous variable. You can have a temperature of like 15.5 or 15.6. So this isn't, a hard and fast boundary value. There are lots of points between 15 and 25. So that's the message that we get from this graph. The second very popular and one of my favorite graphs that you might not have seen before is the box whisker plot. And it has some of the things that we've already discussed. It has for the lower hinge, the first quartile, and I think we saw the rough display of that in the previous video. It has the first quartile, and then we'll talk about the upper hinge. It's got the third quartile, and the median is in the middle. So the 25th percentile, 50th percentile, 75th percentile. And what do? We connect that up with something called a whisker. A whisker connects one of the hinges to the maximum value, one of the hinges to the minimum value. Now, when we discuss outliers, this might not be the maximum. It might be the lowest value that's not an outlier. The highest value that's not an outlier. The lowest value that's not an outlier. So I'm going to have to tweak those maximum and minimums a little bit once we discuss outliers. But for now, I think we're done. I hope I've done a good job in talking about numerical summary measures, a couple of popular graphs, and I do have a second video that goes into much more detail about the box whisker plot. So that's all for now, and I'll see you in my follow-up video on box whisker plots.